Hello, good morning and welcome to Wi-Fi Sheep Live from the Southwest Computer Show here in the heart of Bristol. It's just gone 11 AM GMT and I'm Tom Williamson. Thanks so much for joining us. We're going to be here with you live for the next 6 hours, bringing you interviews, features and the latest news from the world of RISC-OS computing. Now, the main story of the show is the launch of the RISC-OS Direct initiative, a new free Raspberry Pi operating system and a new video series exclusive to us here at Wi-Fi Sheep. If you can make it to the show today, I have one of the new RISC-OS Direct SD cards, which if you are a new or returning user to RISC-OS, you can have for free from the RISC-OS Direct stand out there in the main hall, which is a fantastic initiative. Now, before we go any further, we were hoping to bring you the digital download version of RISC-OS Direct for you to download at home. Unfortunately, that hasn't been possible today, but I am reliably informed that it will be available during the next coming week. So bear with us for that. It's something completely out of my control. I'm as disappointed as you are, but it will be worth the wait. Speaking of RISC-OS Direct, we have a live system here, which we can cut to. And this is our live version running on a Raspberry Pi 3 today. And we'll be using this to show various demonstrations, samples, from various contributors and interviewees during the day. If you are in the southwest area around Bristol and you think you can make the show, it'd be great to see you. We're open now, doors open at 10:30. We're here until 4:30 this afternoon. Details at www.riscos-swshow.co.uk. And a reminder, you can keep up to date with everything that has actually been going on or will be going on our Twitter feed. It's always something that goes wrong, isn't it? But our Twitter feed is at Wi-Fi Sheep. That's at Wi-Fi Sheep on Twitter. A quick look at the schedule for today. At 11:30, we hope to show you the first showing of RISC-OS Direct. At 11:45, we'll have Anthony Bartram from Amcog Games telling us all about the world of development. We'll continue with live feed throughout the day. Now, unfortunately, it's not been possible to get actual live camera feed out in the hall. I was hoping to get various So we'll be back at 11:30 for the very first showing of RISC-OS Direct. We're going to take a short break now and we'll return to the main hall. This is Wi-Fi Sheep Live from the Southwest Computer Show in Bristol. Stay with us. This is Wi-Fi Sheep Live from the Southwest Computer Show. Thank you for joining us. It's just past 11:30 AM GMT and time for the informative and instructional video series all about the versatile and user-friendly RISC OS operating system, brought to you by the Wi-Fi Sheep YouTube Tech channel and RISC OS Development Limited. Over the course of this series, we'll show you how to get started with RISC OS, the many fantastic software, applications and games for the platform, and even how to program and create your own software and apps. For the purposes of this series, we'll assume you're already familiar with using computer operating systems, such as Windows, Mac OS, or one of the many Linux distributions, and that you're aware or even own a Raspberry Pi single board computer, even if you've never used one. What many people don't realise is where RISC OS came from and how established it really is. RISC OS started life as Acorn Computer's first commercial graphical user interface, or GUI. The first versions were built on top of the already established BBC Micro platform and were created for the then new Acorn RISC machine CPU, known today as the ARM processor. From 1987, the first version of RISC OS, codenamed Arthur, was released as the official operating system for the new Acorn Archimedes range of computers. RISC OS continued to be Acorn's main operating system until 1998, when the company collapsed. However, RISC OS lived on and has since been supported and modernised by a number of Acorn clone manufacturers, with products such as the Ionix and later ARM X6 range from Arcomp. In late 2018, the full rights to RISC OS were acquired by RISC OS Development Limited, whom released the OS as fully open source for the very first time. Today, RISC OS enjoys support on a wide range of hardware platforms, including the Raspberry Pi. And it's this low-cost ARM-based single-board computer that we'll be using for the majority of this video series. Getting started with RISC OS couldn't be easier. Before we start, you'll need to choose which Raspberry Pi model to use. Most Pi boards, ranging from the original model A and B from 2012 through to 2018's Pi 3A Plus, B Plus, will work fine. In fact, you'll notice RISC OS runs fast and efficiently even on the oldest Raspberry Pi board. The Raspberry Pi stores all its information, including its operating system, on an SD or micro SD card, with most Raspberry Pis only porting the micro SD. For this demonstration, we'll use this 16GB micro SD card. First, we need to use a Mac or PC computer connected to the internet. Using a web browser of your choice, visit www.riscosdev.com. And from the Downloads tab, click to download RISC OS for the Raspberry Pi. The downloaded .img image file needs to be flashed to the SD card. To do this, we strongly recommend using Etcher, which is available for Mac, PC and x86 Linux systems. Download this software from www.balena.io/Etcher. Once installed and running, select the downloaded RISC OS img file. Next, insert your SD or micro SD card into your computer. If you don't have a SD media drive in your computer, use a USB adapter, but easily purchased online for relatively little expense. In Etcher, select the SD card and finally click Flash. It should be noted that any data on the SD card will be wiped during this process. Once the SD card has been successfully flashed with RISC OS, it needs to be safely removed from your computer. Let's turn our attention to the Raspberry Pi. First, we'll add the newly flashed RISC OS SD card to the underside of the Pi. Next, we'll add a standard USB keyboard mouse. These plug into the Pi's USB sockets. Any USB keyboard will do. However, we don't recommend using Apple USB keyboards, as a lot of them have built-in USB hubs that tend to draw too much power, causing system lock-ups and stability issues for the Pi. On the subject of USB mice, RISC-OS is still designed to use the original 3-button mouse as seen with Archimedes computers, the middle button acting as the same as a right-click on a modern PC. Today, most USB mice have a center clickable scroll wheel. This wheel can be pressed or clicked and will act as a center mouse button. As with keyboards, we don't recommend using older Apple USB mice, as most of these were one button only, which will work but will cause user operational issues. Most Raspberry Pis have a standard HDMI video out port. A normal HDMI cable can be used to connect the Pi to a modern TV. For old TVs or monitors, most Pis also come with a three-way AV jack, which with an adapter will allow for composite analog video. However, this will only be in definition with a maximum resolution of 576i if using PAL video encoding. For users wanting to use older PC VGA monitors, HDMI to VGA adapters can be bought at relatively low cost, and most work fine with the Pi. For our setup, we're going to use a flat screen TV with standard HDMI video. RISC is capable of going online and networking. However, it will require a hardwired CAT or Ethernet connection, as RISC-OS is unable to support Wi-Fi at the current time. A simple and inexpensive patch cable can be used to plug the Pi into a network hub, or if at home, most broadband routers have spare Ethernet sockets on the rear for use with cable devices, and will require some power. We strongly recommend using a suitable micro USB 5V mains PSU with a minimal output of 2 amps. There is no power on off switch with a stock Raspberry Pi, so make sure the main socket power is off or leave the PSU unplugged until required. We're now ready to power on for the first time. First, plug in and turn on your TV or monitor, setting it to the appropriate input, such as HDMI. Now we can power up the Raspberry Pi board. If everything has been followed correctly, you should see the RISC-OS boot prompt appear on screen. Whilst booting, RISC-OS will try to find an internet connection. This may take a few moments. We're now presented with the RISC-OS desktop. RISC-OS's desktop environment works in a very similar way to that of Windows, macOS or even the many Linux GUI front ends. It's mainly divided into 2 areas, the larger desktop space, known as the pinboard, and the smaller icon bar, which stays fixed to the lower half of the screen in much the same way as the taskbar on Windows or the dock on macOS, although it functions slightly differently. On the official Raspberry Pi RISC-OS build, you will notice a row of icons placed on the pinboard. These are shortcuts or aliases for a number of key apps preloaded for you onto the system. Left double clicking on any of these will open the corresponding app in much the same way as it would on a PC or Mac. The icon bar has a number of icons on it as well. To the left hand side, you will see an icon for an SD card. On the Raspberry Pi version, this acts as your main boot drive or hard disk. Left clicking it once will open a window containing all your system's contents, including files, folders, and even other apps. To the right side of the icon bar, you'll see a Raspberry or cog icon. On older RISC-OS systems, this was an acorn logo. Middle clicking this icon will bring up a sub-menu with the option to shut down your computer. When you wish to finish your RISC-OS session, left click this menu option. RISC-OS will then display a dialog telling you it's now safe to power off your system. At this point, you can turn off the power to your Raspberry Pi or, if required, click Restart to reset and boot RISC-OS again. In all, we feel you'll find RISC Direct fast and intuitive to use. Next time we'll look at setting up your system and some of the core apps included and how to make use of them. In the meantime, feel free to look around your new RISC system and don't be scared to go ahead and try out some of the software that's included. For more information about RISC, please visit www.risksdev.com. And if you're watching this presentation on the youtube.com/Wi-Fi Sheep channel, then please don't forget to like and subscribe. There's much more to come in this series. Welcome back. You've just been watching the very first episode of RISC Direct from Wi-Fi Sheep. Apologies for the slight break-up at the beginning of the programme. If you want to see it again, you can watch it on demand now anytime you want on the Wi-Fi Sheep YouTube channel. That's www.youtube.com/Wi-Fi Sheep. And if you haven't already, don't forget to like and subscribe. Right, there's plenty more coming up here at the Southwest Show. This is Wi-Fi Sheep. We are live until 4:30 this afternoon. Coming up very shortly, we're going to be joined by Anthony Bartram of Amcog Games, and we're talking all things RISC game development. Do stay with us. And a very warm welcome back. This is Wi-Fi Sheep Live, coming to you from the Southwest Computer Show in Bristol. And I'm delighted to say we've been joined by Anthony Bartram of AMCOG Games. Anthony, hello.
Hi.
How are you doing?
Pretty good.
Thank you for joining us. I know it's been manic this morning, especially with the bad weather actually getting here. Before we get started, do you want to just give us a little bit of background to what AMCOG Games actually is?
Sure. So I've been running for about 5 years on RISC and released, I think, more than 10 games. I think I had 20 products listed on my stand or thereabouts, this sort of thing.
Oh yes, let's have a look.
Yes.
Yeah.
So that's a collection.
So
if we open it up, there's a little USB stick in there. It's a
okay.
DVD style case, which I thought was quite neat.
Okay, right. So basically, I'm guessing because most of your games are for Pi, which doesn't have disk drives as standard.
Yes.
Is that okay?
Yes.
So we have here. This is AMCOG 2018 collection.
That's right.
And inside, AMCOG branded
You want to probably
USB
hand over
stick.
the code.
Oh, we didn't.
We didn't.
No, it's all right. We're broadcasting such low definition. I don't think it'll be a problem.
I'm suitably reassured. Yeah, so it was just people kept asking me to buy all the games I've released, so I put them all together.
That's absolutely fantastic. Now, as part of the new RISC OS Direct release, we have two new games. Well, I say new games. We have two original games from yourself, now free and part of the OS.
Absolutely.
So let's just cut live to our desktop and maybe just like to just run through what exactly we've got and what we're looking at.
Sure. So we go into diversions, which sorry, it's just me. It's been a long night.
Which is up here.
Frequently, yes. There we go. So we've got Overlord was the game that I released 5 years ago, and then was asked to come along to a show. And then thought I'd start making more games for RISC OS.
Okay.
Because it's 5 years old and because my technology's moved on quite a long way, I thought maybe it was time to give something better back as a free app on the RISC OS store. The other one is I originally did for the Amiga some years ago, and it's an updated and much improved version of Pengo, basically. So this one here is a bit like Gyrus, where you fly into a screen. This one's Pengo.
Well, shall we have a look at Overlord to start with?
Certainly.
Now, we may get sound, we may not with this, I'm not sure, but we'll see.
That's all right. Now, you have the option of playing this in French and German, which is the only game like that. Because I had two of my beta testers were abroad, and they kindly opted
Quite
to...
a lot of the RISC OS community actually are based, especially in Western Europe, I've noticed. So,
I've sent games over to Switzerland and all sorts of
Oh,
places.
really?
Yeah.
Okay.
So it's been fun. I've been asked to do physical copies. So I selected English, so that makes it a bit easier.
So when did this come out originally?
2015. I was writing it for about 10 months. But I got a lot faster. My most recent game I actually wrote a week ago. It took about 2 months to develop, or thereabouts. So it's got a lot quicker. And you can play it with mouse or keyboard. And you've got lots of music tracks. I think there's about 7 in here, and you have multiple missions. So we'll just go straight into it. And you tell me when you had enough. We'll go straight. We'll start on the first level. I think
let's start from the beginning and just get a general just how this works.
So that's it. Space to fire. And you're flying into the screen. So I felt the graphics were much more basic if you compared it to something like Starmine that I did recently.
I was going to say Starmine, that was that for the London show?
It was, yes.
Yes, I remember. We covered it as part of a video on Wi-Fi Sheep. Yes, I remember.
So that's something which is much more modern, really. So you just fire into the screen, you get power-ups, and eventually you get to the boss at the end and destroy that. So it's it's a sort of classic spacer shooter, but in a kind of, instead of being at the bottom screen shooting up, this is
in the middle. Are you in the
that's
middle?
right.
Yeah.
Well, what you are is on something called a Tempest cylinder. So
the
idea of this game is it's a simple way of doing 3D, and it's more accurately called 2.5D. It's not really 3D. It's really just a flat cylinder which you're flying through. I think it creates a different kind of way of playing a game, and it's a model that I really enjoyed when I was young, so I had a go at implementing it.
Now I noticed you have a sprite scaling engine in there.
Well,
how does that work?
So RISC OS comes with sprite scaling available. What I did to make it easier to program is to write a library of functions. Subsequently, I've adapted this into a game engine, which makes it very easy for me to develop games. But if you try, you should always abstract in software. You shouldn't really try to use things directly, because if you do, you make it far too complex. that make sense?
Yes,
You abstract away the
yeah.
complexity, and then your control code becomes very straightforward to write. So I destroyed it quite easily because I wrote it. And this is the easy level. It comes with a hard level. And
So you can change the gameplay almost on the fly.
Well, in the start screen, you can select between beginner and master. The reason for that is that it's more accessible if you have like a starter level. So you've got something here. They've got a little energy wall to go through. You have time bombs and other things to create a varied form of play.
Yeah.
Effectively, and all the source code. The way I've described that is I have like configurations for the levels, effectively. So that's all abstracted away as well.
I was actually going to ask you about the source code. Now, am I right in thinking that most of your games are actually written in BBC Basic?
Yeah, so
Is that correct? Yeah.
That's right. So some of my technology, such as the sound engine, which this game is too old to include, I should mention. It uses Tim Player for playing back sounds. I did the code in BASIC because it made it faster to develop. If you're writing a compiled language, you're going to have to keep compiling, trying, and then rerunning it. And also, BASIC is a fairly straightforward language, and I thought it would help other people understand how these things work. So for all the games I've written, I wanted to try to share knowledge to help other people to try and develop software.
So all your code is actually open source, so people can actually have a look at the source code, see how things actually work.
And they can take that code and use it in their
own
own
really?
projects. It has a bit. You can use portions of this. I would obviously prefer people not to use music and original graphics.
Absolutely.
From the titles.
But from a source code perspective, you're quite happy to be there in the open source community.
Absolutely. I feel that, especially for something like RISC OS, which is a creative platform where people are trying to learn and experiment with software development, it's quite helpful to do that.
Okay, shall we have a look at the other free offering on
Sure.
the RISC OS Direct distribution?
So I shall leave that, and then we'll start Mutant Penguin.
So you said this was a port from Amiga, is that?
Not exactly.
No.
So, well, I did a game called Mutant Penguin in 1994 as a PD game for the Amiga, and what I did was I took the graphics out of that and then just rewrote everything. So this doesn't play the same, and it's got obviously different effects in music, etc. So,
Sorry, you carry on.
No, you go ahead.
I was just going to ask, what are the sort of differences between being a developer for the then Amiga platform and for RISC OS now?
Well, when I was doing it, there wasn't really the internet like we have it now. We had Aminet, which I used to upload to, which was FTP based primarily, and there were PD libraries and things like that. So it was people that I knew were using the Amiga platform immediately and socially, which is why I was doing it. On RISC OS now, you've obviously got these wider communities available. You've got the Raspberry Pi, which is lovely and cheap, which creates a realm of opportunity for people to get involved with it. And it was always more expensive years ago.
Absolutely, yeah. Okay, so sorry, I cut you off there. We'll go back.
Don't worry. It's worth highlighting that on the games, so the most recent games, I've started introducing support for the game controllers, because that's something I meant to do for a while. But by the time I'd done Mutant Penguin, which has always been free, by the way.
Right, so this one has always been...
Correct.
Okay.
Because it's a single screen game, and because the original Mutant Penguin was free, it felt it was appropriate to release this as a free title. But it comes with the standard acorn keys, if we call them that, arrow keys and the WASD keys. So people were asking for things they were familiar with. So I always... Now this is written with the first game I wrote with my development kit, which I made available to make. It's my proof point for it. So this is basically like Pengo, similar to but not the same. So you slide the blocks along. It contains sound effects, which I presume are playing. But I can't
yes, we are getting a sound feed.
Oh, good, that's amazing.
Yeah.
And so you can squash. The idea is to squash these slug-type creatures with the blocks. And then you progress, and if you touch the characters, then you die. So what I did, when I brought the graphics across from the Amiga, they were only in 320 by 256 resolution. So what you can do is you can upscale graphics, and you can calculate and interpolate the missing pixels. And that's what I've done here. I've just used that using an off-the-shelf package, basically. But I have released, as a part of Drag and Drop, an article that explains how you can do this yourself, which is sometimes quite helpful in updating old software.
Absolutely. So, how many levels are in this particular game?
I think there are 10 on here,
Okay.
in this particular instance.
And on average, how long did this actually take you to develop? I know you had assets that came from elsewhere, but on average, how long would it take?
So I'll tell you, I want to give you an idea. Once I wrote Mutant Penguin, I wrote another game called Cyborg, which is based on Cybertron Mission, which is an old BBC Micro game. Cyborg took 2 days to write. This took maybe a couple of weeks because I was developing the game library at the same time.
Okay.
So I was using this as a proof point because underneath here, rather than just having a collection of procedures like I had with Overlord, I had three separate library files, and I had put much more logic into them to make the game much simpler. So the most recent release I've done on this show, which we'll come to in a bit, only took about 2 days to code, and it just took longer to come up with the graphics and the concept, maybe about 2 months or so. So it varies from months to the first-person shooters took more than a year, for example.
But because of the 3D engine.
That was a new thing
So
I had to
are
write.
the 3D games, I'm guessing, are obviously more complicated to do than the 2D. Would that be a fair assumption?
I think so, but possibly now it's become easier because I've got something to work from. So Starmine took maybe a couple of months, and the next one might take less time than that. The reason is once you've solved the problem, you don't need to solve it again, effectively.
You've got the piece of source code that you can reuse.
Correct, and all the library functions and the logic. Exactly. You know the kind of problems you're going to run into. But 3D is more complicated because, for example, in the 2D game, you can just go into the wall a little bit with the character. In a 3D game, that doesn't work that well. You can't see where you're going.
Yeah.
Things like that you have to think about.
Okay. Before we have a look at your latest project, which is it still in a beta mode at the moment? Where are we with that?
So there is a release today. There are some minor things to iron out or improvements I can make, but it's very playable. The beta testers came back and said they didn't find any significant issues. But it's very new. I normally do an update shortly after the show to iron out any minor points. But no, it's sort of an initial release stage, we call it that. Release candidate 1.
So what would you say to anybody thinking about becoming a developer for the RISC platform? What would you say to them to encourage them?
Well, I would say what you should do, one would consider looking at the development kit that I've got. The reason why it has things like error handling that pops up and it makes it slightly easier to manage certain things you don't have to concern yourself with. You see, if you've got what you need to do is keep things very simple. Don't try and be over ambitious. Always develop things in small increments so you deliver something useful. In the case of RISC OS, what's fun about it is it's very interactive, it's very transparent, it's very sort of straightforward in many ways when you get used to it. It's kind of fun. But things like where something's been designed to make it easier to write things, it's worth considering looking at it.
Now you mentioned the development kit. We'll give you a plug for the website right now. So if you're interested in seeing any of what Andy's been talking about or any of the other AMCOG products that are available, you can go to www.amcog-games.co.uk. Okay, shall we have a look at the latest game, which remind what it's called?
Scuba Hunter.
Scuba Hunter, okay.
Right, so this, I'll just start it up. So this is basically it's sort of my take on the Boulder Dash paradigm or Reptron type paradigm, except that I've set it underwater because I like to be a bit different. And because of that, you'll see things in a sideways view. So if we start that, it comes with 10 levels. You can define your own keys if you want to, or you can also use a joystick as well.
Okay.
So we'll go and use the preset keys. You've got, you can access the levels directly.
So just to be clear, this is released, it's available today from the show, is that correct?
Correct, and I will be uploading an updated version to the Play Store very soon, which has had minor improvements and things that people have told me by playing it today. I think would be a good idea.
And for those who have purchased it, will you be offering updates?
All my updates are always free, and if, for example, the product you showed initially, it has a code in there that people can use to download things.
Yeah, we won't talk about that again.
No, don't worry. I should have warned you. So you can collect these diamonds here. Now, the way I made the dive is worth noting. I found a diving instruction video on how to swim, and I drew over the top with a digital pen.
Oh, right.
And then coloured it all in, so it's not exactly like this person. The same with the shark, actually. That's actually based on a real shark. They're quite aggressive, these characters. I think I'll run away from them.
And this is based BBC Basic again?
Correct.
Okay.
So this is using the game development, the game kit behind it. You have to perform things in a certain order. So I went down there first, otherwise this rock would have dropped down and would have blocked it, you see. And it's that type of puzzle that you're dealing with.
So for those who remember Repton on the BBC Micro, it's very much in that vein.
Correct. There are some differences. The diamonds fall, example, because this is a sideways view rather than it being like a sort of hill, which I think that one was. Now I can kill the shark, hopefully, by using these rocks here.
Oh, right, okay.
He's now blown up. If you're not careful, I've managed to make the game unsolvable. So you can kill yourself, but that's going to help you this time. But yes,
that was always the problem, wasn't it?
It's worth demonstrating that. Well, this is the whole point. The game is designed like that. So
things have to be done in a certain order.
Yes. But you don't have to do the whole level in a certain order.
Does it tell you if you've done something that now makes it? Or do you kind of have to...
Unfortunately, you have to find out. This is like it was in Repton.
Yes,
it's the same type of thing, really. But I always found that quite a fun type of puzzle pattern. I thought it was quite interesting to incorporate that in here, rather than just being, shoot all the monsters or just collect all the objects.
Absolutely. I mean, you've got
jellyfish.
The animation you've got there is so is that just sprites tiling on top of each other? Or?
So this is done. So the game kit works with implements a tile library. And yes, I've got an image behind that animates at a different offsets, so creating like a two-level effect. Here's an example of one of those puzzles that you can get caught out with. You have to get those diamonds first before you release these boulders, you see. And I need to make the boulders fall off each other, really. But there you are. That's the basic premise of the game, I think.
Well, that's fantastic. And thank you so much for sharing that
Pleasure.
with us here today. A reminder then, if you're interested in Anthony's games, and you've got, how many titles is it now? Can you remember?
Well, I think this might be the 10th or 11th game.
10th or 11th game?
And there are, on my stands now, I'm studying about 20 different things, including music, etc.
Well worth a look. Again, the web address is www.amcoggames.co.uk. Anthony, thank you very much for your time. You're watching Wi-Fi Sheep. We are live here in Bristol. There's plenty more coming up. Do stay with us. Wi-Fi Sheep live from the Southwest Computer Show in Bristol. Hello there, my name is Tom Williamson. Thank you so much for joining us live on Wi-Fi Sheep. Now, this wasn't part of the schedule, but I'm really pleased and privileged that we've been joined by Richard Brown from RISC Developments Limited. Richard, thank you so much for joining us.
Pleasure to be here.
Now, just explain to everyone a little bit about what's going on with the new RISC Direct initiative and OS that has launched today.
Right. Well, some people may have heard of RISC OS themselves. Some people will not know it at all. But it's a good, compact RISC operating system. You've spoken about it on your Wi-Fi Sheep channel, and you and I got talking back in the summer last year.
We most certainly did, yeah.
About how to get more people maybe involved with it just so that they could see it. And we came up with this joint plan where you're going to do some brilliant videos. I believe the first one has already been streamed out.
Absolutely, the first one, if you want to watch the first video of RISC Direct, it is now live on demand on our channel. That's youtube.com/Wi-Fi Sheep. And it's not just a video series though, because we're following up with an actual Raspberry Pi operating system.
That's right. RISC Direct, as we've called it, is the RISC OS slightly reskinned so that when Tom is talking about this and demonstrating it, as I've seen him do on that first episode, click here, do this, and he's going to take you through the steps, and we've been very happy to commission a whole, I think we've gone to
12 episodes.
12
yeah,
episodes.
12 episodes.
So that instead of having to pick up a manual, which I know a lot of people these days, why do I have to look through a manual? Much better to go on YouTube, see how it's done. So this is aimed specifically at this build that we've put together, and it will be available from the RISC Developments website. I can't give you the URL today. I'll let Tom do that when it's available. It should be available during next week.
Absolutely. If you follow us on Twitter, that's at Wi-Fi Sheep on Twitter, we'll keep you up to date about when the distro is actually available. We think it's going to be about a week. Is that hopefully?
Hopefully. Next week.
In fact, we can actually just have a quick look at the desktop. We were using it to demonstrate with Anthony Barcher from Amcog Games. So lots of things going on here with the desktop itself. This folder in particular is just the one we've had set up for live, but what I'm really impressed about is just the amount of software that's now been added to this distribution. Some of it we're going to go through very shortly, but it's really, really impressive. So we've got everything from games to, probably my favourite actually is the programming folder. And again, we'll be doing some more on this later on the channel. So, for example, we've got Python is this the first time with an official Python build to be bundled with RISC? I think it is.
It's the first one that's been bundled with the
RISC
RISC
yes.
OS build, yes.
And it's not just Python 2, it's Python 2 and Python 3, because anyone who knows about Python will know that the syntax between the two changed, which meant that your Python 2 software wasn't compatible with your Python 3 software and vice versa. So hence, we've got both versions, so we can actually bring Python code over to RISC OS for the very first time. So it's just all stuff like that's really, really exciting.
You are very excited.
I'm very
pleased.
I'm either excited or tired. It's one of the two. So where do we go from here? What's 2020 going to hold?
Well, there will most probably be more updated builds of RISC OS. There are features in there that are being worked on. We need improvement in certain areas. Tom will touch upon those in some of the episodes as they come out. But we've been really pleased with the response from the people that write programs and look after them. I had an email only late last week from one particular gentleman who's got a whole slew of games, and we're allowed to have all of them for free. So we will be doing a games software bundle pack within months. We'll put it all together, we'll check them, and then we will make it available for free to everyone that wants it.
Absolutely superb. And if you stay with us here on the live stream, we're going to go through some of the games that are already come with the RISC Direct build, and we'll be doing that in a few moments' time. For now, Richard, thank you so much for joining us. Richard Brown there from RISC Developments Limited. This is Wi-Fi Sheep live from the Southwest Computer Show in Bristol. We're going to take a short break. Do stay with us. Hello there and welcome back to Wi-Fi Sheep live from the Southwest Computer Show here in Bristol. The time has just gone 12:46 GMT. I'm Tom Williamson and thank you for joining us here live on the channel. Now I thought we'd take this opportunity to have a look at some of the gaming and retro emulators available and built into the new build of RISC Direct for the Raspberry Pi. So we've got the main RISC Direct desktop. Now if you've been watching us earlier on in the day, you'll have seen this in use with a couple of demonstrations. And most of the times you'll be clicking the SD card, which acts a bit like your hard drive or C drive on a PC. So one click down there, and we have a folder called Diversions. Earlier on we showed Overlord and M Penguin, which are games developed by Anthony Bartram of Amcog Games, but there are other things on the system. So, for example, Minehunt, which is your classic Minesweeper PC game that anyone who used any version of Windows, especially during the 90s or early 2000s, will remember possibly at school being bored and playing that. Meteors, which is a clone basically of Meteors, which is pretty self-explanatory. But we also have some new additions. And one of those is actually a port of the 1993 PC classic Doom. So if we double click the app, or the pling, it's denoted by an exclamation mark at the front of the title, so that's how you know these are apps. And you'll see that the Doom icon actually loads down here, so we're going to click once, and it will load straight in. This is a direct port of the PC version, and it uses the free to use shareware edition and map. So let's go new game, and I'm going to set it very easy. Okay, so I'm controlling with the mouse, and if I click, and you can see it's running really smoothly. We're actually using a Raspberry Pi 3 for this, but this will run just as well right back to an original Raspberry Pi, no problem at all, no frame drop anywhere. So if we middle click, we can open doors. I'll apologise in advance if anyone gets motion sickness. If you do buy the is it WAD or WAD files, you can actually still buy commercially for Doom. You can expand the gameplay and have the different levels and chapters. But we've managed to include the free one here with the RISC Direct distro. And that should be the exit gate. There we go. And level complete. And it works as good as that. So we'll just quit out of that one now. So yes, just quit. So that is Doom. Now, you have to remember a lot of RISC OS apps, they will remain open. Doom is no exception. So we have to middle click and quit just to free up the memory that it would have used. Okay, let's move on and look at emulators. Now, this is something quite special for RISC OS, as we have the ability to run both Acorn 26-bit and Acorn 8-bit emulators and software. This is the sort of thing that's not available with other popular retro gaming distributions, such as RetroPie, for example, which doesn't support the BBC Micro or the Acorn Archimedes. Before we go any further, I'm going to now show you a little bit of video of how we went about downloading a new game or vintage app for the system. In this video, we grabbed a copy of the classic space game Elite, and we downloaded a disk image for the BBC Micro and one for the Acorn Archimedes. Unfortunately, we've not been able to get an internet connection directly to this desktop, so we can't do this bit live. So we'll now just segue into the piece of video that was shot the other day. So we'll start at the main RISC Direct desktop, and the first thing we want to do is go to NetSurf, and this will open up down here. So we'll just left click and we get NetSurf home page. I'm going to use the Google search box and I'm going to search for Elite and Ian Bell. And we'll click search. First result that comes up is Ian Bell's Elite Pages. And on his site, let's just maximize that up. There we go. And on his site, he has published elites here. BBC elites. And we've got here the elite disk images. Here's the original disk image. So what we're going to do is, if we hit circle to minimize our web browser, we'll now click the SD card. I'm going to open our emulators, and we've got Acorn 8-bit. And we're going to leave this window open here. Let's go back and let's click to download the Elite disk image, which will create this folder. Now we click, drag, and we'll drop. And there is the Elite image. Okay, we'll go back. Now the next one we're going to look at is for Acorn Archimedes, which is here. And here is the link for the downloading the ARC. So if we now right click close, we go back to the parent directory and we have Acorn 26-bit. So what we'll do is we'll just drop that download in here. So we'll click and we can drag like so. Okay, so that shows you how to go about using the NetSurf web browser to find and download RISC-OS software and BBC Micro disk images. So let's go back to our desktop live. Okay, so we'll start with the 8-bit, and Acorn 8-bit is covered by a program called bbit. If I double click bbit, it will load down here like what you saw with Doom. If I click, we will get a BBC Micro interpreter. There we go. Now you'll notice that it looks a little bit skew if it's stretched. This is a common problem depending on how your video capture is set up, and because we're running our Pi system through a video capture card, it can sometimes play a little bit havoc with a few things. Not to worry. Let's press F12 on the keyboard. If I middle click the Model B icon, let's have a quick look under options, and there's a tab here for display mode. If I ask it high, save and set. Now if I click back, you'll notice the thing is now in the correct aspect ratio. Now this is basically a full functioning BBC Micro, so it will now be able to understand and run all your BBC Basic and 6502 software from the 1980s period. If we want to load up our disk image, let's find our folder that we dumped, which is here. This is a zip. Now we have a program called SparkFS that can actually unzip things just by double clicking, and we have a /SDD disk image here. Now SDD or .SDD is the single density disk, is what it stands for, and that's basically a flashed image of floppy disk containing the software. So what we'll do is we'll just click and we'll drag to get this outside of the zip. Now it comes across as data. We need to change the file type so bbit can understand. If we middle click the icon, go to File, and then there's an option to set type. And you see at the moment it says data. So I'm going to change that to DFS image, all one word. Now notice how the icon is now changed to a 5¼ inch floppy disk. If I now click and drag this icon on top of the Model B down here, You'll notice we launch back into BBIT and the BBC Micro. Now if I go shift and break, on a modern keyboard your break key is sometimes called pause, so it's shift and pause, or shift and break. It will now actually load up the disk image, just like it would do on an original micro. And there we are, that is the original build of Elite. I'm going to hit no. So we can launch now on the BBC Micro. To launch a ship, it was normally F0. The observant amongst you, if you look down at your keyboard in front of you, assuming you're watching us on a computer, you'll notice you probably don't have an F0 key. Do not fear, it is F10 and F10 again. And that will also work just as well. Now, can I remember how this works? It's keyboard driven, of course, so it's S and X go up and down. And I'm trying to remember my left and right. There we go. And it's the bracket keys left and right. Again, it's a good example of getting you motion sickness again. A is shoots, there we are. And there is the whole game. And then when we're done, we can hit F12, middle click, and we can quit. So that's how you would load a BBC Micro ROM or disk image into RISC-OS Direct. Let's have a look at something a little bit more complicated, and that's Acorn 26-bit. This is basically software for the Acorn Archimedes range of computers. And there was the file that we dumped. So let's just double click that again, and this time we have Elite. This is the slightly later version of Elite for the Acorn Archimedes, and this is a Acorn disk image, so slightly different to BBC Micro 1. Again, we're going to do the same thing. We're going to click, drag and drop. Now you'll notice this folder here. Now this is a strange one because it has a pling exclamation mark, meaning it's an app of sorts, but it's also a folder at the same time. If I double click it, there's a nest of icons and a boot directory inside. I'm going to hold down the shift key because I need to move this icon. If you don't and you just click and drag, you'll make a copy to a new folder. So I'm going to hold down shift, click, drag and drop. Now, we're going to try and change this file format. Let's see what it is at the moment. Again, it's data. That's no good to us. And we're simply going to change this to floppy. And you notice it changes to a slightly different type of floppy disk icon. Now, this is a RISC-OS program, but it's an original RISC-OS program. It's not directly compatible with RISC-OS Direct. That's because RISC-OS Direct running on the Raspberry Pi is a 32-bit operating system, whereas the original Acorn Archimedes was a 26-bit system. How do we get around this? Well, RISC-OS Direct comes complete and shipped with RISC-OS 3.11 ROM. If I double click on Acorn mode, excuse me a minute, I just need a drink of water. There we go. You'll see it now boots a completely separate Archimedes RISC-OS free operating system. So we have a different environment and space. All those apps and icons you saw in that folder have now appeared here as the host FS directory, and there is our Elite floppy. If I go into apps here, there's this program, ADFFS. I'll double click that, it loads a folder down here. Now, watch what happens if I click, drag, and drop. It actually opens up the floppy disk, and there is Elite. So we should be able to double click that. And just like it did in RISC-OS Direct, RISC-OS 3 loads the icon down here. Let's click. And you can see the difference in just a few years between the BBC Micro version and the slightly later Acorn Archimedes. We actually have a mouse this time, so there's no F0 needed. We can just click launch. And this is now mouse controlled. And if I click, that shoots. And one thing I always do, I never play Elite properly, is if you attack the space station like that, you'll attract a lot of ships will start coming out of it and you'll get into a dogfight in space sometimes. Let's just turn our power down a little bit. Sometimes, of course, you know, law of averages, as soon as I'm live streaming to you, it's decided, no, that's fine, we're not going to do anything. Oh no, here we go. I think I've got, oh, there we are, something has just come up, space station, where are you? Right. Oh. More training in Elite needed, I think, but you get the idea. So this is now running perfectly fine, and you can do this with a whole host of Archimedes software. Let's hit F12, and we'll quit. Yeah, we'll quit to come out of that. There we go. Now, those were programs that we added, but RISC-OS Direct comes with some vintage games already preloaded here into the 3.11 ROM. So if I click games, these are the games. These come pre-installed with the OS now. They're included. And some of my personal favourites like Cannon Fodder. These were when Acorn still got AAA developers. So Cannon Fodder was across all sorts of different platforms. And this is the little known Acorn Archimedes build. Again, you'd struggle to emulate this using Linux on RetroPie. And that's one of the beauties of having RISC-OS Direct set up the way it is. Okay, what have we got then? And it's one of those sort of slightly quirky click and point shooters. It's a lot of fun. So there's the enemy, and there we go. So it's a bit of a sort of a tactical click and point. There we are, mission complete. Of course, that's just the first level. So I remind you, these are all free and available for you to play. It's slightly unfortunate we've not been able to get the digital download available today for RISC-OS Direct, but as we said earlier in the broadcast, it will be available hopefully this week, and I will keep you updated, of course, on our Twitter feed. Okay, what's going on now then? Yeah, let's not shoot each other. I lost someone. There's only two. Oh, okay. This ain't going so well. But you get the idea. It's a very simple click and point. And we can hit escape when we're done. And control escape will quit an application. If it's not obvious how to quit something, hold down control and escape and you can quit it like so. There's lots of other games on there. We won't go into too much of that Now, I'll leave those for you to explore in your own time. When you're done, there's a shutdown option here, and this won't shut down the whole system, it'll just turn off the 3.11 ROM. So if I double click and click again, you see we instantly return to RISC Direct and our modern desktop environment. Okay, let's have a look now at, we'll quickly have a look at DOS and PC for you. So this is a version of DOSBox, which will give you compatibility for a huge percentage of x86 PC and IBM compatible applications, stuff probably up to around the Windows 3.1 95 era. It doesn't come with a copy of Windows. I do have a copy of Windows actually loaded. So we have a virtual C drive now, and if I type CD Windows Win, it will actually load up, in this case, Windows 3.1. And it's a very usable operating system that you can have inside the space of your RISC desktop, which is extremely useful if you've got legacy applications that you need to run or old files you need to open. You can do it all through the emulator in a very, very fast pace here on the RISC desktop. We'll just close that for now. Now, what I also wanted to show you, twisting over my words now, is, I'm trying to remember where exactly this is. I think from memory it's, yes, it's back under diversions. We have Scum VM, which I'm going to double click. Now, Scum VM, we featured it, I believe, briefly on Wi-Fi Sheep channel itself. It's kind of an emulator and kind of isn't. It's a sort of a front end that allows a lot of selective PC games and multimedia software to actually work on systems it was never intended for, by putting in and recreating the resources needed for the master files to run. So it's not strictly speaking an emulator, but it works pretty much in that fashion. So I've got Scum VM here loaded, and what I want to do is I want to put a PC game and get it running here on RISC-OS. Now, let's just close some windows down so we can see what we're doing. Okay. So before we went, there we are, forgetting where I put things. Okay, so before we went live, I had a PC copy of Myst, which is the classic 3D adventure point and click game from Cyan Worlds, released I think 1993 from memory. I have a PC Windows version of that, the Masterpiece Edition. And what you can do is you can take that disk, you can just put it in a PC and copy all the content of the disk. So it's not copying the disk, it's just copying the folders. And I put it on a USB stick and I put it into a folder called Myst, which is here. And these are all the resources, including the .exes, which of course are all compiled for Windows, so are not going to work on RISC-OS. But here is all the data that makes Myst work. Now, if I go to Scum VM and I click load, oh no, I click add game, sorry. I beg your pardon. So if we go to Myst folder and we click choose, there we go. It tries to identify what it is, and it has it on the list as Myst Masterpiece Edition Windows, so we click choose. That's fine. We'll say, just to check, yeah, we'll go with that for now. So we'll say OK. Now if I click start, you'll see it actually will now launch Myst. Frame rate on movies and video can be a little bit sketchy sometimes. So there we go, Cyan Worlds, of course. And this runs really, really well, considering this is not meant to run A, on the Raspberry Pi, B, on an ARM processor, which is what powers a Raspberry Pi, and C, definitely not meant to be running on RISC OS, but here it is. And it runs really well, and it's the full game. So you can add, if you've got software that ScumVM can actually run, and a lot of the point-and-click adventure games and some of the LucasArts PC DOS era stuff from the kind of early to mid-90s is compatible, and you could actually bring it over and run it here on RISC OS Direct. So there's been a brief overview of gaming on RISC OS Direct and some of the brilliant software and emulators available. We really hope you're going to like that part. So if you're looking for something a little bit different for retro gaming that's not covered by RetroPie, the more popular Linux-based distributions for Raspberry Pi, then really seriously do come and have a look at RISC OS Direct. Well, I really hope you enjoyed that. Thank you so much for being with me. We're going to take a short break now, and we'll be back with more real soon. This is Wi-Fi Sheep, live from the Southwest Computer Show. You're watching Wi-Fi Sheep live from the Southwest Computer Show here in Bristol. Now, we were due to bring you a live feed and showcase from the floor. We were going to go down and talk to many of the exhibitors at the stands, etc. Unfortunately, this hasn't been possible due to limited bandwidth here at the venue. So we apologise for that. If we can bring anyone up for interviews here at the studio, we will do so. Which means the next feature here on Wi-Fi Sheep Live will be our interview with Rob Coleman, which will be all about the video NULA, and that will be at 2 o'clock GMT. This is Wi-Fi Sheep Live. Stay with us. Good afternoon and welcome back to Wi-Fi Sheep Live, coming to you from the Southwest Computer Show here in Bristol. My name's Tom Williamson and thank you so much for your company. I'm very pleased to say we're joined by another guest, a long-term friend of the channel. Welcome to Wi-Fi Sheep Live to Rob Common. Rob, hi, how are you doing? Long day, hasn't it? You've been exhibiting, you've been over there in the second hall. We haven't been able to show people that today, unfortunately, but you've been very busy.
Yeah, so a few of us from the Startup Forum have had some 8-bit machines set up. So I've been showing a BBC Master, mainly running my Pi emulators, so the Amstrad and ZX Spectrum, and had a BBC B running my Doom port. And then Chris Morley, who's also on the Startup Forum, has been showing his Bad Apple demo.
So yeah, well, we'll come back to the Doom port in a bit, but I think a lot of people, especially in Wi-Fi Sheep, will probably know you as the inventor and the creator of the Video NULA graphics card for the BBC Micro. Now we've got here a little bit of footage that we're just going to play over the top of my attempts at putting Video NULA together. Multiple videos, subscribers to the channel will know. Just tell us a little bit about that project, what exactly it is and how it came about.
Yeah, so when I got back into BBC Micros in about 2005, I got given a load of old Acorn user magazines, and just thumbing through them one night, I came across an advert for something called a palette mate created by a company called Wild Vision. So this is in about 1986. And I have to be honest, although I was quite into BBC Micros at the time, it wasn't something I was aware of. And that gave a palette of 4,096 colours and a full 16 colour mode rather than the BBC Micro's traditional 8 colours plus 8 flashing. And so subsequently I kind of looked for one of these. I was sort of really intrigued by it and sort of searched eBay, got in touch with various people. I even contacted Pete Wild, who was the managing director of Wild Vision, or attempted to contact him to see, just to find more about it really. And eventually, because it drew a blank, I decided to bite the bullet and remake it myself. So that's how the Video NULA was born. It started out with just me trying to learn a bit of HDL and knocking together on a prototype sort of circuit board, which I think I showed at the RISC OS Wakefield show back in 2017, maybe 2016. And a few people sort of said, "Oh, I really like that, where can I buy one?" And I was a bit like, well, just...
I was one of those people, yeah.
So yeah, you were very encouraging, as was sort of, there were a number of other people. And so I turned it into a sort of proper sort of PCB design and started making them and sort of selling them on Stardot and a bit on eBay as well. And it's kind of grown from there. So I added various capabilities like smooth scrolling and a Spectrum, ZX Spectrum mode, which allowed me to sort of then emulate the ZX Spectrum.
Yeah, this is quite a feature for the BBC Micros to be able to. It needs a Raspberry Pi board additionally to the original hardware. So a combination of your card, the Raspberry Pi PiTube Direct module,
yes,
two of them together, and it can run, do you say ZX Spectrum software?
Yeah, so I have to, so an admission for me, the BBC wasn't my first love, it was my first computer. My first computer was a ZX81. And so when I got a PiTube Direct, even though I hadn't touched the ZX81 since I got my BBC Micro in 1983, I was interested in kind of exploring that again. I hadn't sort of played one under emulation, so I wrote a ZX81 emulator. And for those who know, the ZX81 has got a very simple character-based display, so it was very easy to sort of write a C program running on the Pi, and then just push the character display across the T-port on the BBC Micro to display the ZX81's graphics. And so that took me probably like, I don't know, a couple of days or so, and I put on the Startup Forum and someone said, oh, you should do it as a Spectrum emulator. You should call it Spectrum because the VC Micro has lots of ROMs.
Yes.
And I thought, yeah, but the problem with that is that the Beeb can't do the Spectrum's attribute graphics mode. And I suddenly thought Video Neural A could. So I enhanced Video Neural A to add that in, and then wrote the Z80 emulator to run on a Pi, and then just push the graphics across the tube port.
So I appreciate you can't see what we're seeing on screen at the moment, but we're actually showing how I created a custom palette.
Oh,
so
yes.
if you have an existing VC Micro game, and let's be honest, some of them great gameplay, gory colours,
Yes.
you can actually, on the fly, without having to change any code, remix the colour palette.
So
Is that
just
correct?
yeah, that's right. So the Video Neural A, effectively, as far as software is concerned, it doesn't know it exists. And what it does is it translates the output from the VC Micro, so the colours come out of it, into an analog palette. So it remaps those colours. So software isn't aware this is happening, so it's compatible with all the sort of original software, all the games they used to play. So, you know, I'm kind of, as you say, aware that lots of VC Micro games are quite garish palettes. You can change them, and the software will run.
We're just looking at SimCity right here, which was a classic one, and it's bright red background and yellow roads, and I have it here with green landscapes and grey, because of course you can have greys and all sorts of colours you could never have originally.
I mean, I was showing someone earlier a Fire Track, which is one of my favourite Beeb games, which the original level is like blue and magenta and looks hideous, but it's kind of like supposed to be in space, so I have it set as 2 levels of grey, and it looks far more like a sort of moon or lunar landscape then.
Okay, let's talk about Doom. Okay, so just to put a bit of context here, you have created a way to get Doom, and we showed the 1993 port of Doom, which now comes as part of RISC Direct running on the Pi. You have it running on the BBC Micro.
Yeah. Yeah.
How?
Right. so back, I guess, last year, maybe, yeah. Someone on the startup forum said, oh, we've got all these new upgrades for the BBC Micro, the Pi 2 Direct, Video Neural A, mass storage. How do we push this to the limits? Couldn't we get Doom running? And I think various people said, oh, well, they're Doom ports for kind of like the Spectrum 128, I think, and we could take the Z80 coprocessor on that. And I just said, hang on, I think there's a much simpler way. If you take the SDL Doom source code, which is for Linux, it's C code. You know, I've written C code with my emulators for the Pi. It's very easy to compile. Why don't we just try compiling that and see how much it worked? So I did, and about 95% of the source files compiled straight away. The only bits that don't compile are the SDL routines that handle the graphics.
Now that's the graphics and video
right.
front end.
Yeah, that's right.
Yeah.
So it's the stuff that does the video, the stuff that does the keyboard handling, stuff that does the sound. There's some stuff in that does networking, which we can come back to. So I essentially just ripped all that out and replaced it with my own routines that send the video data across the Pi, from the Pi, across the tube port to the Beeb. Now that's done in a quite sophisticated way, or at least in an efficient way, so that it renders at a reasonable rate. I think it renders something like 13 frames a second, which, if you look at some of the Doom ports and things like the Amiga, you know, that's comparable, roughly comparable with some of the models at least. And it's smooth enough because the play area is double buffered that you know, it gives you a reasonable experience. The resolution's halved, and
I was going to ask about that. For those who know the BBC Micro, what screen mode is this actually running in, technically?
So it runs in a couple of modes. It can either run in mode 2, if you've got a Video Neural A, it can then use the full 16 colours and the 4096 colour palette, so you get quite a reasonable representation of the play area. But rather than being 320 pixels wide, it's only 160. So
I think that's what we're looking at here on the video, yes,
Okay.
the gameplay, so yeah.
So you'll notice the resolution's halved, but you've got a reasonable colour depth and a reasonable choice of colours. There is another mode for those who don't have a Video Neural A. You can run it in the original mode 1, which was 320 pixels wide, but that's only 4 colours. So I then use dithering to...
Oh, right, so you've actually got a port of this that just uses the Pi module. It doesn't actually need the...
Yes, that's right. So you can run it with just in the 4-colour mode with dithering. And that, to be honest, that looks fairly reasonable because you've got the increased resolution. Although you haven't got the colour depth, it's still playable. You do need some form of mass storage because some of the WADs are like megabytes in size, so they're never going to fit on a big floppy.
I was going to ask about that. So what would you kind of recommend as mass storage? Because there's so many options out there.
So there are now. So I mean, you've got lots of choices. So I have on my BBC B, I have a Go SDC, which has a hard drive image on it. On my BBC Master, which I've got here today, I've got a data center. Again, that is an ADFS hard drive using a compact flash card. But there are other solutions. The Populous or SD card interfaces, I think some builds of the firmware now allow you to have a hard drive image on them.
Okay.
And there's also, on the Stardot forum, there's been a 1 megahertz bus to Pi interface, which is really exciting. And that allows you to plug a Raspberry Pi into the 1 megahertz bus on the Beeb, use that as mass storage, and you also get a number of other peripherals that are emulated as well, like the Music 5000, a RAM disk, and I think they're building other stuff for it as well. So, you know, that's a really good solution. I think that there's recently been a build of these boards or the interface boards on Stardot. I'd certainly recommend looking at those. There's also things like Beep SCSI, which again works really well. It's very fast.
So, I mean, this is all relatively recent development.
Yeah,
It's
the
been
last couple of years, yeah.
I mean, how do you think the sort of scene has grown, especially with the interest in retro and 8-bit seems to be bigger than ever. In relation to the Beeb, how do you feel it's kind of progressed in recent years?
Yeah, certainly. I mean, you look at the number of people on Stardot, on the Facebook group, you know, the interest is incredible. And even if you just look on eBay, the prices that sort of second-hand Beebs go for now, it's really taken off. When I got back into Beebs in 2005, I paid a $5 for a couple of BBC micros. I think you're talking a few hundred now.
Easily, yes.
The bundle I got. So in some ways, you know, that's great. You know, it's great to see people are interested and keen to get hold of this stuff. Obviously, for people coming into it, perhaps the price is a bit more prohibitive, but there are always things like emulators. But just the number of sort of hardware developments really excites me. You know, that, as I say, if you told me when I was, you know, a teenager, you know, sort of younger than that you know, you'd start BBC and people were still doing stuff for them in 2020. You know, I really do think, you know, you had the Pi 2 Direct, you had a hard drive, the machine's transformed. You know, you've got serious processing power. You can use high-level modern languages, and you've got the ability to sort of hold and load massive amounts of data.
I mean, regulars to the Wi-Fi Sheep channel will know my own adventures with the BBC Micro. Some successful, some not, and maybe I've had, you know, a bit of help along the way, you know. So thank you for that, Rob.
You're welcome.
Just going back to your Doom port, is it publicly available yet, or what's its status?
Right, yeah. So I think various builds are out on the Stardot forum. I haven't released it yet simply because it's not finished. I want to get the sound working, at least to some extent. The sound is always the hardest bit with these things, even with the sort of the Amstrad emulator, the Spectrum emulator. Sound is the hardest thing, really, because you've got to map the sound somehow to the Beeb sound system, which isn't the most flexible because it's, you know, fairly high level. I want to get sound in. The other thing I'm working on, and I was hoping to have done it for today, but time has beaten me really, is to get networking going.
Networking?
So, someone's asked me whether we could do a sort of death match kind of across the network.
Which Doom was classic for on the PC.
On the PC. So the idea would be, my master's got an Ethernet card in it, so the idea would be that we could play across the network against someone playing on an ARC or on a PC.
Oh, so it could actually connect to other...
Yeah, using Ethernet, yeah.
So not just Beebs together?
Not just Beebs. Although I would like, I mean, the ultimate aim, if I got on this road, it would be to get Ethernet to, you know, run across a number of Beebs.
Which was Acorn's internal networking.
Acorn's internal networking solution. That would be great. But I've started with Ethernet at the moment just because that's simpler than going straight to Ethernet. But again, that's kind of like a longer-term goal. My first thing is to get sound working, and then once that's done, I'd like to release it.
It'd be fantastic. I'm sure a lot of people would very much enjoy playing Doom. I mean, we're just looking at the footage again here live, and yeah, I can see a lot of people just doing the upgrades to their veteran BBCs. Which BBC models is it compatible with?
So any that's got tube port, so not the compact. You need a Pi 2 Direct. And you need some form of mass storage. If you've got a video neural A, you get enhanced colours. If you haven't, you can use the dithered 4-colour version.
But the more common Model B and Master will work fine.
128 B+, yeah, everything pretty much apart from a compact.
Okay. Well, Rob, thank you very much for joining us here today on Wi-Fi Sheep Live. A reminder that if you missed any of today's broadcasts, you can watch it again on our YouTube channel. That's youtube.com/Wi-Fi Sheep. And for updates about what's going on and our continued schedule, head over to Twitter. That's @Wi-Fi Sheep on Twitter. We're going to be doing some programming and coding demonstrations coming up very shortly. Until then, we're going to take a short break. Stay with us. You're watching Wi-Fi Sheep live from the Southwest Computer Show. A very good afternoon. The time has just gone 3 o'clock GMT. And now if you missed it earlier, there's another chance to see the first edition of RISC OS Direct. And welcome to the first edition of RISC OS Direct, a brand new informative and instructional video series all about the versatile and user-friendly RISC OS operating system, brought to you by the Wi-Fi Sheep YouTube Tech channel and RISC OS Development Limited. Over the course of this series, we'll show you how to get started with RISC OS, the many fantastic software, applications and games for the platform, and even how to program and create your own software and apps. For the purposes of this series, we'll assume you're already familiar with using computer operating systems, such as Windows, Mac OS, or one of the many Linux distributions, and that you're aware or even own a Raspberry Pi single board computer, even if you've never used one. What many people don't realise is where RISC OS came from and how established it really is. RISC OS started life as Acorn Computer's first commercial graphical user interface, or GUI. The first versions were built on top of the already established BBC Micro platform and were created for the new Acorn RISC machine CPU, known today as the ARM processor. From 1987, the first version of RISC OS, codenamed Arthur, was released as the official operating system for the new Acorn Archimedes ranges. RISC OS continued to be Acorn's main operating system until 1998, when the company collapsed. However, RISC OS lived on and has since been supported and modernised by a number of Acorn clone manufacturers, with products such as the Ionix and later ARM X6 range from Arcomp. In late 2018, the full rights to RISC OS were acquired by RISC OS Development Limited, whom released the OS as fully open source for the very first time. Today, RISC OS enjoys support on a wide range of hardware platforms, including the Raspberry Pi, and it's this low-cost ARM-based single-board computer that we'll be using for the majority of this video series. Getting started with RISC OS couldn't be easier. Before we start, you'll need to choose which Raspberry Pi model to use. Most Pi boards, ranging from the original Model A and B from 2012 through to 2018's Pi 3A Plus or B Plus, will work fine. In fact, you'll notice RISC OS runs fast and efficiently even on the oldest Raspberry Pi board. The Raspberry Pi stores all its information, including its operating system, on an SD or micro SD card, with most Raspberry Pi only putting them. For this demonstration, we'll use this 16GB micro SD card. First, we need to use a Mac or PC computer connected to the internet. Using a web browser of your choice, visit www.riscosdev.com. And from the Downloads tab, click to download RISC OS for the Raspberry Pi. The downloaded .img image file needs to be flashed to the SD card. To do this, we strongly recommend using Etcher, which is available for Mac, PC and x86 Linux systems. Download this software from www.balena.io/Etcher. Once installed and running, select the downloaded RISC OS img file. Next, insert your SD or micro SD card into your computer. If you don't have an SD media drive in your computer, use a USB adapter. These can be purchased online for relatively little expense. In Etcher, select the SD card and finally click Flash. It should be noted that any data on the SD card will be wiped during this process. Once the SD card has been successfully flashed with RISC OS, it needs to be safely removed from your computer. Let's turn our attention to the Raspberry Pi. First, we'll add the newly flashed RISC OS SD card to the underside of the Pi. Next, we'll add a standard USB keyboard and mouse. These plug into the Pi's USB sockets. Any USB keyboard will do. However, we recommend using Apple USB keyboards, as a lot of these have built-in USB hubs that tend to draw too much power, causing system lockups and stability issues for the Pi. On the subject of USB mice, RISC OS is still designed to use the original 3-button mouse as seen with Archimedes click on a PC. Today, most USB mice have a center clickable scroll. This wheel can be pressed and will act as a center mouse button. As with keyboards, we don't recommend using older Apple USB mice, as most of these were 1 button only, which will work but will cause user operational issues. Most Raspberry Pis have a standard HDMI video output. A normal HDMI cable can be used to connect the Pi to a modern TV. For older TVs or monitors, most Pis also come with a 3-way AV jack, which with an adapter will allow for composite analog video. However, it will only be in standard 5.6 if using PAL video encoding. For users wanting to use older PC VGA monitors, HDMI to VGA adapters can be bought at relatively low cost and most work fine with Pi. For our setup, we're going to use a flat screen TV with standard HDMI video. Modern RISC OS is capable of going online and networking. However, it will require a hardwired CAT or Ethernet connection, as RISC OS is unable to support Wi-Fi at this current time. A simple and inexpensive patch cable can be used to plug the Pi into a network hub, or if at home, most broadband routers have spare Ethernet sockets on the rear for use with cable devices. We strongly recommend using a suitable micro USB 5V mains PSU with a minimal output of 2 amps. There is no power on off switch with a stock Raspberry Pi, so make sure the main socket power is off or leave the PSU unplugged until required. We're now ready to power on for the first time. First, plug in and turn on your TV or monitor, setting it to the appropriate input, such as HDMI. Now we can power up the Raspberry Pi board. If everything has been followed correctly, you should see the RISC OS boot prompt appear on screen. Whilst booting, RISC OS will try to find an internet connection. This may take a few moments. We're now presented with the RISC OS desktop. RISC OS's desktop environment works in a very similar way to that of Windows, Mac OS or even the many Linux GUI front ends. It's mainly divided into 2 areas, the larger desktop space, known as the pinboard, and the smaller icon bar, which stays fixed to the lower half of the screen in much the same way as the taskbar on Windows or the dock on Mac OS, although it functions slightly differently. On the official Raspberry Pi RISC OS build, you will notice a row of icons placed on the pinboard. These are shortcuts or aliases for a number of key apps preloaded for you onto the system. Left double clicking on any of these will open the corresponding app in much the same way as it would on a PC or Mac. The icon bar has a number of icons on it as well. To the left hand side you will see an icon for an SD card. On the Raspberry Pi version, this acts as your main boot drive or hard disk. Left clicking it once will open a window containing all your system's contents, including files, folders and even other apps. To the right side of the icon bar, you'll see a Raspberry or cog icon. On older RISC-OS systems, this was an acorn logo. Middle-clicking this icon will bring up a sub-menu with the option to shut down your computer. When you wish to finish your RISC-OS session, left-click this menu option. RISC-OS will then display a dialog telling you it's now safe to power off your system. At this point, you can turn off the power to your Raspberry Pi, or, if required, click Restart to reset and boot RISC-OS again. In all, we feel you'll find RISC-OS Direct fast and intuitive to use. Next time we'll look at setting up your system and some of the core apps included and how to make use of them. In the meantime, feel free to look around your new RISC-OS system and don't be scared to go ahead and try out some of the software that's included. For more information about RISC-OS, please visit www.riscosdev.com. And if you're watching this presentation on the youtube.com/Wi-Fi Sheep channel, then please don't forget to like and subscribe. There's much more to come in this series. And if you want to watch that episode of... In about 10 minutes time, we're going to be doing some live programming with our build of RISC-OS Direct, so I hope you can join us for that. In the meantime, we'll take a short break. This is Wi-Fi Sheep live from the Southwest Computer Show. Stay with us. Hello and welcome back. This is Wi-Fi Sheep live from the Southwest Computer Show here in Bristol. My name is Tom Williamson. Thank you very much for joining us, and thank you for those of you that have stayed with us throughout the entire day. It's been a long day. We're nearly getting to the end of it, but we've still got lots more coming up here on the live broadcast, including programming, which is what we're going to look at now. Now, today has seen the launch of RISC Direct, a new video program that you've just seen on the channel, and also a standalone Raspberry Pi distribution, allowing for new users to hopefully pick up the RISC Acorn platform. On this new build, we have a number of programming tools and languages open to you, and that's what we're going to look at now. So let's swap over to our live desktop. So this is what RISC Direct will look like when you get an SD card or the digital download. A quick reminder that the digital download version is a little bit delayed and hasn't been available today, and again, we're sorry about that. That's a situation very much out of my control. It will be available hopefully during the week. Stay tuned to our Twitter feed, that's at Wi-Fi Sheep on Twitter, and we'll update you as soon as you can download it. Anyway, let's look at some programming. So on our main pinboard or desktop area, we actually have a folder called Programming, which you'll double click. And I'll just go through very quickly what is actually here. So, for those of you that are familiar with code already, we do have a C compiler, which is the common GCC compiler. Anyone who writes the various versions of C will be familiar with GCC, so that's included. We have PHP for anybody who does web development or web servers. That's a very common server-side language, and we have a stack available there. RISC Lua, which is a build of the Lua programming language, which I have to admit is a personal favourite of mine. That's also included. We do have BBC Basic, a modern version of the classic BBC Basic that originally shipped with the BBC Microwave. This is a 32-bit edition. We'll come back to that in a moment. But I want to show you Python. So, RISC Direct comes shipped with Python 2 and Python 3. And if we double click, as you can see, here are the two Python interpreters. We also include Python 3 here on the pinboard. So if I just double click, it will open a new task window, and there is the live Python 2. And we should now, fingers crossed, be able to do the same thing. Yes, we can. And there is Python 3. If I go Control and F12 to bring up a blank task window, and I ask for Basic, just type Basic, there is BBC Basic. So we've now got two Python interpreters and a Basic interpreter open, live, and waiting for code. Now there are a few differences, and this will change as the build progresses, but right now this is Python 2, so let's try putting some code in. So if I say print quote mark hello, press return or enter, and you see we get hello and it reports back. However, if I try to do that in Python 3, so exactly the same thing again, it fails. This is the thing to remember, that Python syntax changed between version 2 and version 3, which did render a lot of the version 2 code unusable or unreadable if you only had a version 3 interpreter. So to make this work, I'd actually have to put print, open a curly bracket, put my text in hello, close bracket, and now that actually works. BBC Basic, if we try that again, that will also fail and not be valid, because BBC Basic is case sensitive. So the print command has to be in uppercase. So print, oops, let's spell that correctly, there we are. And there you are, see, so there's how three different interpreters work. Now there are other things we've got built in, so we'll see if this works. So Python 2 on RISC Direct has Pygame. That's Pygame is in the gaming and visual desktop module that came included with the stock Raspberry and Raspberry Pi Linux builds. We've got a working copy of that here. So if I try and import the module, so I type import Pygame. Now you notice how it says there's a slight error here. That's a known bug. It's an unfortunate bug, but it's a known bug in the system. We're working on it. So we'll just close that. No big deal. Open up another one. Let's just try that again. And there you go. Second time it loads in. So it says hello from Pygame community. Can't read in front of me now. So we know that's now working. Okay, so we've got these interpreters, and we'll close those to say, yep, we're done. Now what I have got is some code, which I have in our live folder. So this is Python code. Sorry, we've got an announcement going on in the other room, which is throwing me off. Okay, so what we now have is we've got a Python 3 file and a Python 2. And if we middle click and look at the file type, Python 2s can simply be called Python, and that is the file type. Python 3 files need to have the 3. And what we can do is, let's say we want to open this heads and tails code. Now this has come from Keris Lock of the Stafford Raspberry Pi Jam, and at the end of each Pi Jam event, it's mainly for kids, they have a sort of like a raffle heads and tails game, a kind of party game if you remember from a kid, and they actually give away prizes, sometimes whole Raspberry Pis as a result, and they have this piece of code which they normally run on Raspbian. Now if I hold down Shift key and double click, we can have a look at the code. So this is Python 3, and we're importing the random module, and the random module is used to generate random numbers because that's not stock to Python. And you see HT equals, then we create a list, so heads or tails, and then we print random choice HT. So if I double click, it generates a task window. It says heads. If I double click again, heads again, heads again. Come on, give us a tail. Heads. Come on, give us a tail. Hey, there we go. There's a tail. It does work. You see how simple it is to just load Python. There's no having to go through an interpreter. There's no having to click run or whatever that you normally have to do on Raspbian. It will just work. Now, the Python 2 I want to show you has Pygame. I can't remember if I mentioned that Python 2 on this is the only one that has the Pygame module installed. It's not available in Python 3 just yet. Again, it will be a work in progress. Let's just have a quick look at the source code for that. It's a little more complicated. So you can see we import Pygame, and then we set up some parameters or variables, so background color, height and width, screen, and then we're going to call pygame.display, and that's a module that comes over from importing Pygame like so. Now, hopefully, if I double click this, there we go, it actually generates a window in RISC-OS. It will do exactly the same thing if you run this on Linux, Mac OS or Windows. It's now got that level of compatibility with RISC-OS. So what we could do is we could, for example, change the background color here. So I've got it purple, so let's go 255, middle click, and we need to save. So we've now got 255, 255, 255. These are the R, G, and B, red, green, and blue values of the background color. So if I reload, you can see it's now white. And if I take green and blue to 0 and leave red at 255, again, remember to save. Let's reload. we now get the solid red. So you can see how you can use these values to mix colours and create backgrounds. This is a very simple tutorial, but you see how we can create an application, or game even, and we can actually delete graphics within Windows, and it all works within RISC OS. And again, this code would be virtually fully compatible with other OSs. Okay, let's have a look at BASIC. This is the more classic BBC BASIC, which I'm sure older audience members are probably more familiar with. Now we have BASIC app here on the desktop. This is one of my own creations, and a simple double click will launch the BASIC interpreter, and it switches into full screen mode and in mode 7, which is the classic BBC Micro booting mode. So this is full BBC BASIC, so all your BBC BASIC commands, remembering to put caps lock on, will work. If you don't have caps lock and you try, it will fail, and we can actually switch modes on the fly. So there's mode 2, mode 1, mode 0, and when we're done we can just type quit and we come back to the desktop. So what you can do is you can create a simple game, and I have a game I've been working on here, Space Shoot /BAS. BAS is the file extension for BASIC, and if we look at the file structure here, set type, it's BASIC. We double click, it will load. Oops. I can remember what my keys were for this now. Oh, it's arrows. There we go. So arrow keys back and forth, spacebar shoots, and it's a sort of classic, quick Space Invaders. I held down Shift, I can double click, and we'll have a look, oops, at the source code. We don't want to do that. There we go. And you'll notice that there's no line numbers. With modern BASIC, indeed with modern Python, you don't need to include line numbers if you're not referencing a line. So for BASIC, for example, there was the classic go to 10. In fact, we can do that now. Let's do that code now and I'll show you. So let's clear the screen. So 10, print I, 20, go to 10, oops, 30. You don't actually need to put end because you never get to line 30, but we'll put it in anyway. If I run, there you go, and then we can hit escape when we're done. He says one thing of his machine is actually just locked up, which it might have done. Oh, that's brilliant. You couldn't make it up, could you? Right. But we're going to have to restart that, I think. I'm very sorry. That's hilarious. Oh, wow, we've really gone. Okay. We're going to take a short break, and I'll be right back with you. This is Wi-Fi Sheep, live from the Southwest Computer Show. Welcome back. Okay, I think we're back up now. I'm not sure what happened there. We'll have to investigate that. But yeah, you couldn't make it up, could you? Anyway, the point I was trying to make is that normal BASIC needs line numbers to work. Now, we have a program here called StrongEd, which if I double click and we click again down here, it brings up, it looks like a text editor, and that's effectively what it is. But it has something called base mode. So if I middle click and then change mode, you see all the different languages I can code, and that includes BASIC. So, now before the problem was that if I put the command let's make sure we've got uppercase on. If I go to 10, for example, it needs a line number to actually reference, but we don't actually have to have line numbers. So we could, theoretically, go with CLS to clear the screen, and we'll say always allow that action. Clear the screen. Repeat. Print hi. Notice how it already indents for you. In BASIC, you don't have to have indenting, it just does it to clean it up. It's not like Python where if you don't have the correct indenting, the program fails. BASIC is very happy. You can have as many spaces in there as you want. It normally doesn't have a problem. So we've asked it to print hi. And we'll say until false. And you see how that now goes back on the next line. So you can see where the repeat starts, what we're going to do, and until it's false. So we click the running man icon, let's see what happens. And there we go. So it's actually brought up a window and it's looping. Because we didn't declare a screen mode, it's just looping in a window within the RISC-OS environment. If I hit escape, it escapes, and that brings us back. So if I go CLS, and let's try mode 7. I'm nervous to do this because I think it's going to crash again, but we'll see what happens. Right. And I was right. I think there's a little bit of a problem there, which is always typical for these live demonstrations. But yeah, so that's kind of how that works. I've generally never seen that before. But oh well, we found out these things together. Just trying to bring the machine back online, there we go. Yeah, so that's fundamentally how the programming aspect works. Obviously there's a slight issue there with the screen modes that will need to be addressed. But the most of the stuff, as you saw, works perfectly fine. Just don't try and go hi mum 10, go hi mum 20, go to 10. It yeah, generally has a way of breaking things. Ah, brilliant. Okay. All right, let's go back to our desktop again. All right, so most things work perfectly fine. So you've got your Pythons there, PHP, we've already talked about Lua. Let's bring back up what I was working on, which back under live. So I actually have a series of programs. What have we got? Probably not in that folder. There we go. And this is a series of basic stuff which I've written before. So we could try my 3D engine. And this is all basic, and this basically generates a 3D cube. It's quite simple. It's not brilliant. There's better demonstrations of 3D coding than this, but it's something I've done. And if we wanted to have a look at that code, we shift double click, and you can actually see how the code works. And again, no line numbers. They're not required if you're not referencing lines in BASIC. And yes, just to answer a question on the live chat from Rick Murray. Rick, thank you for joining us, staying with us all day. Yes, Python enforces indentations. So if you don't have the correct line structure in Python, it will crash. BASIC shouldn't crash, but is on this demonstration. Oh dear. So, and yes, we actually are streaming with a Apple laptop for the broadcast software. But yeah, so it's all fun and games. But that's basically how this works, and we should be able to run. Yeah, that works fine. We can escape. Let's discard that. One final thing I'll show you, and we're going to do this, cover this in much more depth on the Wi-Fi Sheep channel at a later date, is I've actually got the basic code for a text adventure. It was called Silver Mountain, and it was released in the 80s by Usborne Books. And it's one of these type-in, you basically have the book, you type the listing in, and you can play the game. So here is the listing. Notice the line numbers are back. And that is because there are statements here that reference the lines. So hopefully, there we go, we can actually play this. So we'll start a new game. And it's not massively thrilling, but so we go. W. Notice how if you don't have uppercase on, it doesn't recognise where you want it to go. So you're at a bridge. You can go east, north. And you kind of get the idea of how that would work. When we're done, we can hit escape. And there we go. One thing I did do, and I have it here in a zip, is I did create a full-blown app out of that code. So let's just click and drag that onto here. So you see it now has an icon and has an exclamation mark, which signifies it's an app, or what we call a pling. If I shift and double click, it actually opens it as a folder, and I have an obey run file. I have that source code, which is pretty much here. And you see how it just said that line numbers can't be stripped because they are being referenced. And we have an obey file, which is a text file, a bit like a system command. I'm trying to think, like a bat file on Windows for a bit like a bat file on Windows. So that's kind of how that works. And what we can now do is we double click, and I've added a little bit of a front end to it, so press spacebar to continue, and then it's pretty much the same game as seen before. So there's lots of possibilities here with RISC-OS, and we're really hoping that new developers will come on board and either port code over or will want to start writing games or apps for the system. And we're going to be covering this in more detail on Wi-Fi Sheep and also as part of the RISC-OS Direct video series. Well, I hope you enjoyed that brief demonstration of coding on the platform. Again, as I said, we'll be covering that in more detail at a later date. Right, I think it's time for another break, and we'll be back real soon. You're watching Wi-Fi Sheep live from the Southwest Computer Show. Thanks for being with us. Welcome back to Wi-Fi Sheep live from the Southwest Computer Show. Unfortunately, we've had a few technical issues in the past few moments, which means we're not going to be able to bring you the interview with Brian Hogan today. Again, I'm really sorry about that. These things happen. It also means we're going to be bringing our broadcasting to an end. So we're going to be closing very shortly. I want to say thank you so much for all of you that have stayed with us throughout the entire day. If you have enjoyed broadcasting and want to support us, please consider joining us on Patreon. That's www.patreon.com/Wi-Fi Sheep. There's lots of extras and perks available if you join, and you can join for as little as $1. If you haven't done already, please do like and subscribe to us on Wi-Fi Sheep. There will be a highlights program or version of this live broadcast going up shortly. You'll be able to watch the whole broadcast in real time back as well. And also you can follow us there for update and new episodes of RISC OS Direct. The time is just coming up to 4 p.m. GMT. On behalf of everyone here at the Southwest Computer Show, I would like to say thank you once again for your company. Really hope you enjoyed the broadcast, and I hope to see you real soon. Wherever you are in the world, this has been Wi-Fi Sheep Live. A very good night.